Okay, so I'll be talking about the air quality forecasting system and how it is helping to manage the day-to-day air quality in Delhi NCR region. So Delhi is one of the global hotspots in terms of pollution, and it is extremely difficult to manage the level of air quality levels we see in Delhi. But yeah, and if you look at the exposure of those air quality levels, somewhere around 40 million people get exposed to these high levels of air quality. If we look from the mid October and early March, the air quality levels, daily air quality levels are so high that even you require the management on day-to-day scale. So the regulatory authorities in India, like Ministry of Environment, Forest and Climate Change, Central Pollution Control Board, and Commission for Air Quality Management, they approached us and they said us that it is difficult for us to bring in the policies which will immediately control the air quality in Delhi, but we need a forecasting system based on which we can at least control the day-to-day air quality levels in Delhi to some extent, so that we can reduce the exposure for extreme air quality events. And on their request, we started developing this air quality early warning and decision support system, and now it is operational for since last 5 years. And this is actually closing a loop that we are talking with the policymakers. Policymakers are taking the forecast, and then they are actually implementing the management measures to control the air quality in Delhi. Down arrow. Okay, sorry. So this is actually the summary of the system. Uh, you can see. Yeah. So this is actually a summary of system. This is an integration of many different components, and the heart is basically the air quality model. But the system also talks with the observations and make the course correction when we run the forecast. Uh, it's not shared. Yeah. Okay. Okay. Yeah. And yeah. So we actually what how this system in what way the system works. So we run a air quality model at 10-kilometer resolution. The model is basically a FUNCHEM model. We run it at 10-kilometer resolution, and then we dynamically downscale it to the 2-kilometer resolution covering entire northern India, and then we zoom in over Delhi at 400 meter resolution. The emissions which we use for driving this air quality model is the HTAP version 2 emission inventory. But for the Delhi NCR region, we have our own emission inventory, which is at 500-meter resolution. So we drive the localized emissions for Delhi NCR, not only for Delhi NCR, but all the metropolitan cities and major urban centers. So we have our own emission inventory, and we infuse those emission inventories into the Edgar HTAP emission inventory. So this is one part of the system. Then this system also talks with the observations, all the observations, whether it is coming from the satellite or ground-based observation. So we do assimilate air quality, this Modi's aerosol optical depth at 10-kilometer resolution to improve the initial condition. But the problem with Modi's aerosol optical depth is that now it has stopped, and now we are switching over to the VRS aerosol optical depth. But the sensitivity of VRS is not that much good to 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 reproduce the air quality level, but we are working on that. And at the same time, India has launched a new satellite, OceanSat 3, so it is also giving the aerosol optical depth, and we are trying to assimilate that data also. So at 9 UTC, we assimilate the aerosol optical depth from satellite data, and then we also assimilate all the air quality monitoring stations across India. So there are 400 monitoring stations. So all the data from this air quality monitoring system stations goes into the system. For fire data assimilation, earlier we had a fin emission inventory, but the fin has a problem that you don't get a real-time fire emission. So we developed our own utility similar to kind of fin emission inventory, but we get local information, like we take fire count, which gets available somewhere around 5:30 in the evening, and then we convert that fire information into a fire load using the sentinel based vegetation map, and then using crop to biomass ratio and local emission factor. So Rupal has already talked about this in her studies presentation. So we do a lot of fire data simulation also, and then finally we drive the model with FUNCHEM and Kalpan filter GFS IITM IMD GFS model, which is running at 12.5 kilometer resolution, and also we do conventional data simulation for improving the weather forecast in the model. So this is how this model runs. So we fire forecast every day somewhere around 6 UTC, and this forecast goes till midnight when we get final product at 400-meter resolution for Delhi. In second domain also, we again do the data assimilation of surface stations which are situated across Delhi NCR region. Coming to DSS, so this system is also implemented with a lot of tracers from different sectors like energy sector, transportation sector, and industrial sector. Many sectors have been traced into the model, and these tracers are implemented for PM 2.5 and PM 10. And we also trace the emissions coming from the surrounding region of Delhi, and there are 24 districts which might contribute to the air quality in Delhi. So we trace all the sectors and all the districts which contributes to the air quality in Delhi, and that's how we get also the information about what is contributing to the elevated levels of PM 2.5 in Delhi. Whether it is a Jhajjar district which contributes on a some day to the air quality in Delhi, or it is a transportation sector or industrial sector. So this information is very important, and then you target the actions for day-to-day air quality management. Yeah, and this is how, this is the forecast we generate on daily basis. This is the actually evaluation of forecast on third day. So third day forecast at 4 p.m. because usually the Central Pollution Control Board report air quality on that day for 4 p.m. So we try to evaluate how good is the forecast, and you can see that the forecast is extremely good. It captures all the variations in the PM 2.5 levels in Delhi, be it 50 microgram per meter cube, the lowest concentration, or be it a 400 and 450 kind of AQI, which we see in Delhi. So most of the days it captures the variation in PM 2.5, and so that means that this system is extremely useful to make the decisions for this is the graph 1 or graph 2 should be activated, or graph 3 should be activated, or graph 4 should be activated. So graph are basically a graded response action plan set of the measures which we activate once the air quality reach to that level. If you look at the 5 years of overall performance of this system, you can see that this model or this forecasting system is very good in producing the air quality levels falling in very unhealthy category or unhealthy category. The probability of detection and success ratio is extremely close to the 100. So the kind of levels which fall into this category, we are extremely successful in reproducing. But for the critical air quality conditions, when air quality forecast goes beyond 400 AQI, we still have challenges. And those challenges, you can see that mostly the underestimation is occurring when the biomass burning season is very active in northwestern India. And we still don't have a very accurate fire emissions that is going into the model. Although assimilation is compensating some of the fire emission, but by and large, the fire emission inventory is so uncertain that you are basically failing to capture the air quality levels that we see during the peak biomass burning season. And you also get some underestimation when the fog season is very active. So the model is not able to reproduce the fog, and therefore the gas to particle partitioning is not occurring, and we are actually not able to capture those dense fog event when air quality is crossing the critical levels. Okay, so this is how this system works, delivers the forecast, and then finally this forecast goes to a policymaker. So policymaker, basically we have three policymakers in Delhi. One is Pollution Control Board, another one is Commission for Air Quality Management, and Central Pollution Control Board. So every day we generate a forecast for 3 days. That forecast goes to the Commission for Air Quality Management, then they decide based on the air quality level we predicted for next 3 days whether we should activate the graph 1 kind of conditions, graph 2 kind of conditions, or graph 4 kind of conditions. And once they decide that okay, we'll activate the graph 4 condition, then that information goes to 150 different agency in Delhi NCR that actually then try to manage the things like they stop the construction activity, they stop the inflow of heavy vehicles in Delhi, and even they try to manage the burning fields in the state of Punjab and Haryana by issuing a lot of notifications to the ground level, like some panchayat level, block level kind of information they issue. And this is how the we can control the air quality by managing the day-to-day activity. So this is one of the example of how we manage the air quality in Delhi. So if you look at the red one is the predicted air quality for during somewhere around 11 to 16 November. So we predicted that air quality will go beyond critical air quality levels, but then based on forecast the government imposed a lot of extreme restrictions, like they shut down the heavy traffic flow inside the city. They implemented the odd even kind of traffic restriction. Constructions activities were stopped. All the polluting industries, they were stopped, and you can see the improvement because of those restrictions. So we predicted that air quality will go beyond will touch around for 500 AQI, but then we could restrict it below 400 AQI. So this is the kind of improvement we saw. So overall improvement, if we look at it, was we could improve the air quality, or we could avoid the severe events, and we could restrict that to the only poor kind of event. So this is how this is actually occurring in Delhi. Something okay. I think right hand, left hand side figure is not working, but again for fire, because we also give the fire forecast, how much fire contribution will stubble burning will contribute to the air quality in Delhi, and for next 2 days what will happen, how the plume will travel. So we have developed some AIML based fire forecasting model that has a success of 63%, but it gives you indication whether the meteorological conditions are conducive when the fire is occurring. So we give forecast, and based on those forecasts, they also go to the farmers. They convince them, okay, you burn the fire, but you don't burn the fire for next 2 3 days, so that meteorology is conducive. It will transport the plume. Either you burn when the event is going, is happening, or not when happening, you don't burn the fire, or you burn earlier. So that kind of actions they take place, and some of the actions actually materialize. Not every farmer listen to that, but some of the farmers listen to that. Yeah, and this is a kind of overall summary I'll put up, how the air quality system is activating different stages of graph. So you can see that graph 1 is throughout active in the winter season. Graph 2 when air quality comes, the graph 3 and graph 4 stages you don't get often, but those are extreme cases when you get a lot of heavy air pollution, but those then we activate those based on the forecast. And during that period, you can look at the air quality level. So those are basically very poor, severe, and severe plus, and this is how the graph activation takes place. So activation and revocation occur based on forecast, and how much improvement we get because of that forecast. So you can see that once you activate the graph 2 and graph 3, you get reduction in PM 2.5 of the order of 150 to 200 microgram per meter cube, and that translate into somewhere around 80 to 100 units of AQI. So that is a good success of controlling air quality, not allowing air quality to cross the critical levels. And what are the benefits? You can see that those benefits, if we control those air quality levels, you get avoided death of somewhere around 290, 300%. So short-term exposure to this air quality can be reduced, and you can save the lives of 300 individuals only by controlling, or only by putting those actions in place. Yeah, and then what is happening to the air quality? These are last my 2 or 3 slides. So there are policies which are taking place since last 10, 15 years. Some are the like short-term policies, some of those are long-term policies, and they are slowly getting implemented. Whether those policies are really penetrating into the Delhi's air quality, whether we are getting benefits of that air quality policies. So the answer is yes. We have long-term measurements of PM 2.5 and PM10 in Delhi, and you can see that the air quality, particulate matter pollution, PM 2.5, PM10, they are steadily decreasing. Although the rate is not too high, but the quality is really getting improved, and the levels are decreasing steadily. And in terms, shit. Which one? Huh? Yeah, this one. I have just finished last two slides.
Almost there.
Yeah. Previous one. Yeah. So the air quality levels are steadily decreasing, and if you see at the index, the poor days, number of poor days are really decreasing since last 10 years. Very poor days also decreasing. So right hand side is PM 2.5 and left hand side is PM 10. And basically the severe events are drastically decreasing. So this is a kind of policy penetration is occurring, and we are able to now control the air quality levels in Delhi. What about biomass burning? So biomass burning also you look at the burnt area, not the fire count, but the burnt area. You can see that in October there is a steady decreasing the area which is getting burnt. So in 2016 it was somewhere around 35 million square kilometer, but in 2023 the October only burned 22 million square kilometer of area. And similarly in November also you can see that there is a steady decrease. So that communication is going into the farmers are taking steps, but there are certain issues, those are not related to actually farmers are not willing to burn the fire. It has something to do with the supply chain, how can they manage so the huge amount of biomass that is getting generated, and the time they get for disposal of that biomass. Yeah, thank you.
Thank you so much for a great presentation. Questions, a lot of questions.
Fascinating, very nice presentation. Where do you run this system? Is it at IITM or at NCAR?
No, it's at IIT.
Okay. Very, very impressive work.
Thank you.
Just a quick question out of curiosity. The last plot about the sentinel data about unburned area, is it only about stubble burning? How can we know that, because it is burned area?
Yeah,
so it should contain
so that work is actually done by Rupal. So initially she mapped the crop fields, so where the rice is grown, and then that area, if you get a burnt in that area, only those areas we have mapped, not the other area. So that scrutiny she has done.
Yes.
Thank you very much. I also echo her sentiments. It's really interesting, and also maybe one of the few talks I could follow. Anyway, so I'm just wondering, given the massive changes that you're showing in levels, how sensitive is the forecasting model to minor or modest air pollution changes?
No.
That's the first one. And in terms of measures, I saw that you had various sectors, including open waste burning, which is a critical element of our emissions on the continent in Africa. So are you planning to expand more, or are you just mainly focusing on the wildfires and agricultural burning? And the third one, sensitivity of the downscaling of the model to a smaller scale. So moving from urban scale maybe to local streets or neighborhoods where a lot of decision making would impact not only just the policymakers but the users at the other end. Yeah, and is this part of the work that is going to be for East and Southern Africa?
Rajesh is looking into that. So I'll go in a reverse mode. Coming to very localized forecast is we have been trying to run the LES model to have a localized kind of air quality management, because there are so many things which are coming up, erratic things. The people are putting the a kind of smoke guns to suck the air and clean the air, but that is not going to happen, because if you look at the layer, it is 1 kilometer thick air, and you cannot just put some small chamber, suck the air and clean the air. And some suggestions are also coming, and actually money is getting wasted on that. People are sprinkling the water on squares, this traffic junction, to reduce the air quality. So to test those hypotheses, we will probably be implementing the very high resolution AES scale model. Yeah, and the decreasing trend, that is not actually model-based forecast, it is actually the observations. So we had a long-term observations right from 2010 till now, and based on those long-term observations, we have seen a steady decline in PM2.5 levels. And what was middle question?
It was to do with open waste burning.
Yeah, open waste burning. So we have trash emission inventory, but it's difficult to capture this open waste burning. Yeah. So we have one project going on where we are trying to look at the markers of open waste burning and how much that is contributing through measurements. But then you cannot get the information about the location where it is getting burned.
Yeah, Savitri from Thailand. Thank you very much for your insight talk. And actually, we have the same comments from the farmers as you have in India. My quick question is, how you, in your forecast model, how do you integrate the plume rise, or you consider that it's actually at the surface?
No, actually, if we turned on the plume rise parameterization in the model. So whatever default parameterization is there, that we have turned on.
So you choose the
We
default?
we use default plume
Okay.
rise parameter. Yeah.
Thank you.
Thank you for the very great talk. I just want to confirm that when you are trying to evaluate the biomass burning, you didn't use training, but you used kind of a models and various hotspot data. And how did you convert? You were trying to evaluate the estimate of pollutants from that data. Could you elaborate a little bit more on how you did that?
Yeah, so one of the thing what we have seen, basically what the utility we have developed for fire emission is solely based on the fire points, the fire detection. You know? So if you detect the fire, you estimate the emission. But in India, what we have seen that many times you miss the fire. And now farmers have become smarter. They don't burn the fire at the satellite passing time. They burn after that. Yeah, that information has gone to the farmer. They burn somewhere around 3 to 4, and then quickly spray the water so that this thermal detection should get avoided. So that's why we try to move from the this fire detection based on the fire point to the burnt area. If we detect the burnt area, we know what kind of crop is there, we know what is the crop to biomass burning ratio, and then estimate the fire. But the difficulty with burnt area is that Sentinel doesn't give everyday burnt area product. It takes 5 days to revisit. So that is what.
First, you determine the location where the fire happening using a hotspot data, and then you convert it based on biomass and emission factor or something. You calculate it by yourself.
Yes, yeah.
So I had a couple of quick questions. The satellite that you're launching, is this going to be geostationary and be able to solve this problem for you?
Yeah. So we are planning in 2026 to launch a air quality satellite. So that will mostly focus on air quality related issue and the profiling, basically weather profiling, thermodynamical profiling. So that satellite will be coming in 2026.
It won't do thermal hotspot.
Yeah. But geostationary will not give like precise hotspots. For that, again, we need to rely on this OceanSat 3 on US 6. But the problem with that satellite is that it is looking at atmosphere at this wavelength at 550 nanometer. It is not giving AOD. It is giving somewhere around 680 nanometer.
And my other question, since I'm copying Adriana's, is how does in your most severe restrictions, and you calculate the amount that you improve the air quality from doing that, how does that compare to what you saw in the lockdowns and COVID? What fraction of amount cleaned up did you achieve by this?
No, so during lockdown, everything was shut down, and we got tremendous improvement in PM2.5 and PM. So like in winter period, we used to get PM2.5, mean PM2.5 somewhere around 220 to 40 microgram per meter cube. But during lockdown, it came down to 60 microgram per meter. But 660 was still there. It is beyond the air quality standard prescribed by our Indian national standards.
Most cities are shocked when it gets to 60, just saying.
Yes, yeah. But for 60, for us it is very normal.
Thank you again for the
Thank
great
you.
presentation.
Thank you so much.